Hi guys, my name is Vivek, and over the past few weeks, few people have reached out to me to understand how the index are stored on the database, what is root block, what is branch block, what is leaf block, and how the index splitting works. So I'm going to explain all that quickly in this particular tutorial. I have a quick request: if you have not subscribed to my channel already, please go ahead and do it now so that you get a notification as soon as I upload a new tutorial. Now let's go ahead and understand the concept of index splitting and index spawning using this particular example. So I'm going to go ahead and create this particular table IDX split. Let me go ahead and create this table. Now I'm going to insert 100 rows in this particular table. The data has been inserted. I'm going to create a unique index on this particular table on the ID column. The index has been created. Now I'm going to analyze this particular index and validate its structure so that I can gather the required stats. Now I'm trying to see what is the height of this particular index, how many leaf blocks this index contains, and how many branch blocks this particular index contains. So if you see, the height of this particular tree is 1 and it has just one leaf block and no branch blocks. Now guys, if you have not seen my previous tutorials on indexing, leaf blocks actually contain the physical location where the data is stored on the tables, while branch blocks only have a pointer to the leaf block. So in this particular case, I don't have any branch blocks, I only have one leaf block. Now let's go to our PowerPoint presentation and understand what this means. So when I created an index on my table, this is what exactly happened. Here is my leaf block and it actually physically contains the address where the data is being stored on my table. This particular 1, 2, 3, 4 and 100, it represents my ID column, and this row ID is the unique address where the data is being stored physically on the table. So guys, when we have very less number of rows, you have a single block allocated to the index. This particular leaf block will act as the entry point of the index. It will act as the root block. So if you run a query and the optimizer decides to use the index, it's going to access this particular leaf block, and based on the row ID, it's going to go to the table and fetch the data. Now let's go ahead and see that when I further insert more rows in my table, what is going to happen to my index, and then we will learn the concept of index spanning and index splitting. So now I'm going to insert another 1000 rows to my table IDX underscore split. The rows have been inserted. I will go ahead and analyze my index again and validate its structure so that the stats are reflected. If I go ahead and directly query it, it will not reflect the change. So I will have to validate its structure again. Now when I run it, I will see that the height has changed, and now I have 2 leaf blocks and 1 branch block. Now let's go ahead and switch to our PowerPoint presentation and see what exactly happened. So previously we just had 100 rows and they were stored in a single leaf block. We didn't had any branch blocks. But now that we have inserted 1000 more rows, we have 2 leaf blocks and 1 branch block, and this is how it's going to look like. My branch block does not have the physical row ID where the data is being stored on the table. It just has a pointer to the leaf blocks where the data is being stored. So my branch blocks only have pointers to my leaf blocks. It has these two values reflecting that if you want to access any ID which is less than 550, you go ahead and access those values from the left leaf block. And if you want to retrieve an ID which is greater than 550, you go ahead and retrieve that value from the right leaf block. So this process where the height of the tree has increased is called index spanning. Earlier we had just one block allocated to our index. The height of the index was 1. Now that we have inserted more data to our base table, the height of the index has increased. It has increased to 2. And this phenomena of vertical tree growth is called index spanning. That means when the height of the index will increase, that phenomena is called index spanning. Now what exactly will happen if I go ahead and insert more rows in my base table? Let's switch to our SQL developer and see what exactly will happen. So when I inserted 1000 rows, I saw that the height of my balance tree index was increased from 1 to 2. That height increase or the vertical growth of my balance tree index is called index spawning. Now what I'll do is I will go ahead and further insert 2000 rows in my base table, and we will see how my index will change. So I'm going to insert another 2000 rows here. The rows have been inserted. I'm going to analyze my index and validate its structure. So if you see, I have only one branch block, but my leaf blocks have increased significantly. I have 6 leaf blocks now and the height is same. So the phenomena of horizontal growth of our balanced tree is called index splitting. So let's quickly switch back to our PowerPoint presentation and see what exactly it means. So earlier I had 2 leaf blocks and 1 branch block and the height of tree was 2. Now that I've inserted 2000 more rows, the number of leaf blocks has increased, but the height is still the same and the number of branch block are also the same. The height is 2 and the number of branch block is 1. So let's see when I will go ahead and insert further row in my base table, how my index will shape up. So here in this case, we will see that we have certain changes. Now my branch blocks has 3 pointers because we have 3 leaf nodes, and my second branch block, initially it had entries till 1100, it accommodated some more entries, and when this particular block was full, it actually split it into another block. Now the blocks can actually split in 2 ways. Either you can have 50-50 splitting or you can have 90 or 99-1 splitting. What exactly that means? When this particular second block was completely filled, a new block was generated, and if there is a 50-50 split, that means half the data or half these ID values were copied from the old block to the new block. This is usually done when the data load is not consistent. In this particular case, we have an incrementing value which is consistent. That means every new value that will be added to this particular index will be higher than the previous one. And guys, this is actually very common, which leads to index block contention. And in my next tutorial, where I'm going to explain reverse key index, I will explain what is index block contention and how that can be resolved using reverse B-tree index. But for now, when this particular second block reached its threshold where it could not accommodate any more ID or row ID values, it actually split it into another block, and some of the data can either be copied from my old block to the new block, or in this particular case, since we have incremental values, I will retain all the old values in my previous block and the new value 1201 will be written to my rightmost block. So this particular phenomena where a new block is added on the same level and the height of the tree is not changed is called index splitting. And guys, at this point of time, I want to say one thing, that index splitting actually happens very frequently, and if not configured correctly, it can actually lead to index block contention, which can lead to performance issues, especially when multiple sessions are trying to update same block, as we will see in the case of numerically increasing values like order ID, or in this case of ID column or transaction ID column. Now I'm going to insert 2 lakh rows to my table, which will show that a number of leaf blocks will be added. That means there will be considerable amount of splitting, but we won't see any spawning if at all. So let me go ahead and insert this data. The data has been inserted. I will analyze the index and validate its structure real quick. And the height, ideally it should be 2 or it may increase to 3, but my leaf blocks, which were earlier 6, will be increased considerably. So if you see, the height is still the same. We only have 1 branch blocks, but the leaf blocks have actually increased considerably from 6. Now we have 380 leaf blocks. That means a lot of index splitting happened. So guys, let's just quickly recap what we have learned as of now. If we have very few number of rows in our table, we will have a single block in our index, the leaf block, which will have physical address where the row is being stored on the database. That leaf block will act as the root block or the entry point of the index. As we will go ahead and insert further rows, it will lead to index spawning. Earlier, when we had a single leaf block, the height of tree was 1. When we insert further rows in my base table, as we saw, we will saw index spawning. Now we will have multiple leaf blocks and a single branch block. The branch block will only contain the pointers to the leaf block. So as we saw, we had 2 leaf blocks which contained the physical location where the data is being stored on disk, and the branch block only had pointers to that particular leaf blocks. When the height changes, that phenomena is called index spawning. Then we saw another phenomena which was called index splitting. So when we were inserting data further in our base table, our index was growing horizontally. That means the height of index was same, but the number of leaf blocks were increasing constantly. We saw an example where we had 2 leaf blocks, and when we inserted more data in our base table, after a certain point my leaf block could not accommodate any further entries, so there was a block split. A new block was created, and based on the data or based on the type of index that we have, we can have two splitting strategy, 50-50 strategy or 90-10 strategy or 99-1 strategy. Usually with numerically increasing columns, Oracle actually opts for 90-10 split strategy or 99-1 split strategy. So hopefully after watching this tutorial guys, it is clear how the index are stored on the database, what is index spawning, what is index splitting, and in my next tutorial, which is on type of B-tree index, I will explain index block contention and how we can go ahead and deal with it. Thanks a lot guys for watching this particular tutorial, and I'll see you in the next one.